Okay, so ladies and gentlemen, welcome back to our Math 2511 online lecture. In today's lecture, we will try to focus on two useful indicators to evaluate the performance of an investment fund over a year. So which are the dollar weighted rate of return and the time weighted rate of return. Okay, so both indicator is actually we try to use that to measure our fund performance in a particular year so that we can decide whether we want to stick to the fund or just will try to withdraw it and choose another one. Now, to start with, so let us consider this scenario. So let's suppose I got an investor. Okay, so who is holding the fund at time 0, so which you regard it as the beginning of a particular investment year. Okay, and then let's suppose for this investment fund, so it has the value A. Okay, so this is the initial value of this fund. Okay, now and then here so we try to consider the following. So let's suppose in the coming year, so this investor will try to keep this investment fund, and also over this year, then he will make some deposit. So let's assume that we invest the additional amounts of the C1, C2, Cn at some time over this year. So let's denote it by C1, C2, Cn. Okay, so these are the additional deposit. Okay, now and then of course by making this deposit and together with the interest earned by this fund, then after 1 year, then this fund value will go to another amount, so which is equal to B. Okay, and of course we will expect so this value will be very different from A because of the additional deposit and perhaps the additional interest earned over this year. Now and then what we are going to do is, so we want to evaluate the performance of this fund over this entire year. Okay, so that means so we try to measure so how much interest is being earned by this investment fund. Okay, then of course the easiest way to do that is you try to measure it using the IRR, isn't it? So remember, the IRR is the annual effective interest rate, which try to tell you the exact amount of the interest earned by this investment over the year. Okay, so here then let us try to measure it using this IRR. Okay, so first of all, let's suppose that we let I be my IRR. Okay, so in that cases, so your accumulation function of the fund will be this AT equal to 1 plus I to the power T. So given this accumulation function, okay, then now we can try to say something about the value of the fund after 1 year. Okay, so here we let the B to be my the account balance after 1 year. Okay, so here this account balance will be just equal to the future value of your deposit and also your account balance at the time 0. I mean the initial one. Okay, so here then given this accumulation function, then you can easily find this future value. Now, so for the first term, that will be what? The future value of your initial account balance, which is A at time 0. And then the second term will be the future value of the additional deposit. So remember, we have make n deposit here. Okay, so then that will be our future value. Okay, so here then if you substitute your accumulation function, then this is the equation that you are going to get. Okay, now And then here, let's suppose you know the account balance at the beginning of the investment year, end of investment year, and also you know the deposit, then you can try to solve this equation for the I. Okay, now but of course here, given this equation which is non-linear, then of course the best that we can do is we can only solve this using the Newton's method and try to get the approximate answer. Okay, of course mathematically it work, but some people will complain it may be too tedious to do so because you need to first of all define your function fk, find the derivative, set up the iteration formula, and then you need to use the Excel or keep on pressing the calculator and get this I. And definitely most of you will feel very painful to do that, right? So here, what we are going to do is, so instead of using the Newton's method, is there any other way to find a easy answer for this I? Okay, so here, in order to do that, so what we are going to do is, so we will try to make some simplification to this equation. Okay, now, so here remember, when we try to calculate the interest earned by this fund, okay, or maybe when we want to develop this equation, so we have made one assumption, right? So what is that? So that is, so we assume that the fund earn the compound interest. Okay, so that you got your accumulation function, and then you set up this equation, and then you solve an I. Okay, now and then because we assume this compound interest, so that the equation is complicated. So here, in order to simplify the structure of this equation, so what I'm going to do is, so instead of assuming that it earned the compound interest, so we will try to assume that it earned the simple interest instead. Okay, now of course some people may say, so it seems like that this is something need to be inconsistent to what happened in real life, because we believe that every account in the real world should earn the compound interest. But the reason why we do this approximation is because here we only talk about 1 year time horizon, so which is relatively short. Okay, so here we will expect that, so whenever you use the simple interest or compound interest, so actually it does not make a huge differences. Okay, so here, okay, so what we are going to do is, so we will try to assuming that the fund earn the simple interest instead. Okay, now so in that cases, then what will happen? So so originally under the compound interest, so our accumulation function is 1 plus I to the power t, so which is what we have if we assume the compound interest. Okay, and now what we are going to do is, because the 1 year time horizon is short, okay, so we will try to approximate it by the simple interest, which is at equal to 1 plus it. Okay, so we use this to do the approximation instead. Okay, of course we can mathematically justify this roughly justify this approximation using the Taylor expansion. Okay, but here this is not really very important at this point. Okay, so here let us try to apply this simplification and try to see whether we are able to simplify the equation into something easy. Okay, so here then this is what I do. Now, so remember under the compound interest, so your I does satisfy this equation, right? Okay, now and then here what I'm going to do is, so we will try to apply this approximation and approximate 1 plus I to the power t by 1 plus it. Okay, now and then here given this, then you can try to simplify the equation in this particular form. Okay, now so for the first term we only have 1 plus I, so this one does not have a very big matter. Okay, but here for the second term, so we have 1 plus I to the power 1 minus tk, so which is something little bit tedious. So what I'm going to do is, so we will adopt this approximation. Okay, and then approximate this guy into this 1 plus 1 minus tk times I. Okay, so which is the lower one, simple interest. Okay, now and then here, so given this, So given this, then the resulting equation now become just a linear equation for I, so which we can easily solve it analytically. So then to solve this equation, so you first try to group up all the term involving the I, okay, which is here and here, and then you group up all the term like that, okay. And then here, if you try to put this coefficient to the left, then you will find that the I will be given by this formula. Okay, so here then this will be what the approximated formula for the interest earned by this investment fund. Okay, and here this return rate is what we call the dollar weighted rate of return. Okay, so here, okay, then this is the definition. Okay, so here so we let A and B be the fund value at the beginning of the year and at the end of the year respectively. Okay, and then let's suppose, okay, we have some contribution made within this 1 year period. Okay, then the dollar weighted rate of return will be a kind of approximated IRR of this investment fund. Okay, so which is given by this formula. Now then the next thing is, so you see, so this formula is very complicated to memorize, right? Okay, so here in order to help you to memorize this formula, so let us try to give some meaning on the term in the numerator and the denominator. Okay, now first of all, for the numerator, so that will be what? B minus A minus the summation of CK. So actually this one represents the amount of the interest earned by this fund over the year. Okay, so how do we get this? So now remember, for A is the initial account balance at time 0, right? And then after a series of deposit and also the interest earned by the fund, then this account balance jump to B at time 1, right? Okay, so here given this, then we will expect that so the change in the account balance, okay, will consist of two things. One, of course, will be what? The deposit made over the entire year, okay, and plus what? Plus the interest earned by this investment fund. Okay, now and then here we let the interest earned by the fund to be, for say, I, okay, and then here, okay, over this year, so you make the deposit C1, C2, Cn, so that the total deposit will be what? The summation of this CK. Okay, so here then if you try to put this term to the left, so then you will find that the interest earned will be equal to what? The difference in the account balance minus the sum of the deposit. So meaning that the numerator is just what? It's just the interest earned, okay, over this year. Okay, now then the next thing is, so how about the denominator there? Okay, now so for denominator, it consists of two terms. So one is what? Your initial value of your investment fund. Okay, so you can try to treat it as your initial deposit. Okay, and then you also have the sum of this CK. Okay, so which is what? Your additional deposit. So that means the numerator actually is sort of the total amount of your deposit, okay, that you make. Alright, now and then here if you look at this formula, it looks like that the formula is not that simple, okay, because here so you see for each of the CK, so it involves this additional coefficient 1 minus TK. Okay, so remember what is TK? So TK is the time that you make the deposit CK, right? And then the 1 minus TK is just what? It's just the time that this deposit stay in this fund. Okay, and here when we calculate this total amount of the deposit, so you can see, so we will try to adjust the amount by this constant. So why it is so? Okay, because here, alright, so we believe that, so let's say if the amount stay in the account for a longer period of time, then we expect that it should earn more interest. Okay, so in particular here, let's say the A, okay, you invest at time 0, and then because it stay into the account for entire 1 year, right? Okay, then definitely it should earn a lot of interest. But if you consider another extreme, like the last deposit CN that you make at time N, and because it stay into the accounts for only 1 minus TN year, and definitely, so we expect the account, the interest earned by this deposit will be less. Okay, so here, okay, then in order to try to measure this interest rate better, so what we do is we will try to adjust each amount, okay, by adding this additional weight. Okay, so this 1 minus CK can be regarded as the weight we assign to each deposit. And if the deposit is made earlier, then we try to give a larger weight because it stays in the account in a longer period of time. Okay, so here then this is the basic structure of this dollar weighted average of return. So just summing up, so this I is just simply equal to the interest that you earn, and then divided by the total amount of the deposit. So which is the traditional way of measuring the interest rate, right? Okay, but just for the total deposit, so we will try to adjust the total deposit by adding the weight to each of the deposit, and simple as that. Okay, so here then this is about the interpretation of this dollar weight of return. Okay, now and then here let us try to run through a couple of examples and just try to have some idea on how to play with this notation. Now, so here in example 9, so which is one problem in the past SOA exam. Okay, so in this problem, so we consider an investment fund owned by a person called Peter. Okay, so here you are given that, so in on 1st of January, okay, which is the beginning of a year, so we know the account balance is 56,000. Okay, and then we also know that, so after 1 year, which is at the end of, which is the 31st of December, okay, which is end of year, then it will grow to 72,150. Okay, now and then here so we are also given that, so over this year, so this Peter, okay, will make the deposit into this account. Alright, perhaps he try to deposit part of his salary into this investment fund. So in particular here, at the end of each month, okay, so which is 1 over 12, 2 over 12, 3 over 12, and then okay, and then he will make this deposit. Okay, which is 1125. Okay, and you try to make it at the end of every month. Okay, so then this is the first thing. Okay, now and then of course and then here, besides making this deposit, so this investor will also make the withdrawal as well. Okay, so in particular here, so on 30 of April, okay, so which is the end of the 4th month, okay, so he will withdraw the amounts, sorry, so careless. Okay, so at the end of the 4th month, okay, so he will make the withdrawal $500, okay, and then on 5th of October, okay, so which is the mid of October, so which is at 9.5 over 12, okay, so he will make another $1,200 dollar deposit, withdrawal, okay, and then at the end of the November, okay, so he will also make the withdrawal 1,000. Okay, so here, okay, then this is when he do the withdrawal, okay. Now, and then so here, so this is what happened to his investment fund over this year, okay. Then what we want to do is, so given this information, so I want you to evaluate this investment fund over this year. So in particular, so I want you to calculate what is the dollar weighted rate of return over this year, okay. Now, so here, in order to get this, so first of all, you can first try to recall the formula, okay, of your dollar weighted rate of return. So let's call it I. Okay, so remember, according to the definition, so the I is just equal to what? Equal to the total interest earned by the investment fund, right? Okay, and then divided by what? Divided by the total weighted sum of the deposit, right? Okay, and remember, we are not talking about the total amount, is the weighted sum, okay, adjusted by what? The time that the amount stay in the account, okay. Now, so how do we get this there? Okay, now, so first of all, let us first calculate the total interest earned by the fund, okay. Now, so just remember that how do we get this? So we do this by considering the differences. It's differences in the account balance, right? And remember, this account balance is driven by a couple of parameters. First of all, is the amount of the deposit that you have make, okay, and of course it also be affected by what? By the withdrawal, right? Isn't it? And of course, when you do the withdrawal, so it will lower the account balance. So that's why you have the minus sign. And then of course, other than this, so you also have the interest, right? Isn't it? So here, then this will be what? So then that will be what? The Gaussian equation of the interest earned by the investment fund. So here, in order to get this denominator, so what you need to do is, first of all, you consider the account balance, the differences of the account balance, which is what? 72,150 minus 56,000, so which is the difference of the account balance, and then minus the total amount of the deposit, so which is 12 times 1125. Okay, remember, we make 1125 at the end of every round, so you have 12 deposit. Okay, and of course, in addition, so you also need to add back the withdrawal, right? Okay, so which is 500, 1,200, and then plus 1,000. Okay, and of course here, okay, so you can of course the withdrawal can also be regarded as the case when you have the CI to be negative. Alright, but anyway, so this is so what you get in the denominator, so which is same as what I wrote in the solution. Okay, so if you calculate this, so you will find that the value is 5350. Okay, now, and then once you have this, then you can now do the you can work on the denominator now. Okay, so remember, for the denominator, so that will be what? The total weighted sum of the deposit. Okay, now, so here how do we get this? So then to do that, then you try to collect, so over this year, so how much money is being put in the account or being taken out of the account, so which is this, which is the amounts that we have here. Okay, now so and then of course when you consider each deposit, so you also need to multiply by the time that it stay in the account. Okay, now so first of all, let us start with the account balance. So that will be 56,000. Okay, and then it stay the account for the entire year, so that you have one. Okay, now and then the second step is you can look at your deposit. Okay, so here, okay, you make the deposit at the end of every month. Okay, so so let's say, okay, if you consider a particular deposit that you make at the end of the K month, so it will stay in the account for 1 month K over 12 years. So in that cases, so then you multiply this deposit by 1 month K over 12. Okay, and then you have 12 deposit in total. Okay, so that you take the summation and the K running from 1 to 12. Okay, so then that will be your deposit. Okay, and finally, of course, you also have the withdrawal as well. Okay, because it also affects your account balance, right? Okay, and then of course in the context of the withdrawal, so it will be considered as a case you have the negative CI. Okay, so that in that cases, so you try to for each deposit, so for each withdrawal, okay, so you multiply this amount by the amount is stay into the account. So let's say for the first one, it stay into the account for 8 months, so that you have this. Okay, and then for the second one, so that will be 1 to 12. Okay, and then for the last one, 1,000. Okay, so that will be 1 month 11 over 12. Okay, so here this is how do you get the denominator. Okay, so which is the one that I present in the solution as well. Okay, so here by calculating this, so you will find that this the denominator, okay, which is the weighted sum of the deposit, will be just 61,520. Okay, then once you have this, then you can now try to calculate the dollar weighted rate of return. So which is just the amount of the interest that you earn divided by the deposit. Okay, sorry. Okay, then you will get the final answer, which is 8.69%. Okay, so here this is just a quick example about how do we calculate the dollar weighted rate of return. So personally, I would not suggest you to really memorize that complicated formula. Okay, so actually what you need to do is just try to understand the meaning of this I, and then when you start with the problem, okay, so I guess it's better for you to start with this verbal formula. Okay, and then you just get your numerator and denominator one by one. Okay, so which is something that we have done, okay, in the earlier chapter properly. Okay, but just one thing you have to be careful is, so when you calculate the denominator, okay, so make sure that you are considering the weighted sum. That means for each deposit, you need to multiply the amount by the time that it is stay into the account. Okay, and then another thing is, so when you encounter the withdrawal, okay, so like here, then you need to change the positive side to -1, because it will be treated as the negative deposit. Okay, so here then this is just a sample calculation of this dollar weighted rate of return. Now, and then perhaps let us look at another example about this. Okay, now so here for this in this example, so we will consider an investment fund over this entire time horizon. This time horizon from 1st of July 2016, so which we treat it at time 0. Okay, and then up to 13th of June 2017, so which is time 1. Okay, now and then here first of all you are given that, so for this investment fund, so the initial account balance is 120,000. Okay, and then after 1 year, so it will grow to 153,200. Okay, then of course we expect, so it will be cased by the the interest earned, and probably the additional deposit. Okay, now and then here in this problem, so you are given that so over this year, so you have three deposit. So the investor has made 3 deposit in this investment year. Okay, and then you are also given that for this 3 deposit. Okay, first of all, the time period between 2 consecutive deposit is 1 month. All right, so that means here, so for this 3 deposit, so we deposit at time t, and then t plus 1/12 and t plus 2/12 respectively. Okay, so each period here is exactly equal to 1 month. Okay, so this is what this statement means. Okay, and then here you are also given that for this 3 deposit, so the amounts will be S, 2S, and 3S respectively. Okay, that is the second condition. And then the third thing is, so you are also given that the amount of the interest earned over this entire year is 9320. Okay, so which is your I. Okay, now and then in this problem, so what we want you to do is so we will try to ask you about the detail of this 3 deposit. And here in this problem, so let's suppose I give you the dollar weighted rate of return is 6.9588591%. Okay, and then my question here is, so I want to know, so when do we make this first? When do we make the first deposit? Okay, that is that is I want you to try to find out the t. Okay, so that you can tell in which day you are going to make this deposit. And then here so to facilitate the calculation, so we will assume that there are only 30 days in a month. Okay, so that we have 360 days in a year. Okay, now so here how do we solve this problem then? Then of course here, in order to figure out this exact date, then of course the easiest way that you can do is you can try to find the values of this t. Okay, so then that will be our target. Okay, now and then here in order to get this target, definitely you have to try to set up the equation for this t first. Okay, and then of course one equation that you can, so one condition that you can try will be this dollar weighted rate of return. Okay, so remember the dollar weighted rate of return is what? 6.9586591%. Okay, so let us try to use that to set up the equation. So remember, so the dollar weighted rate of return is just equal to what? It's just equal to the total amount of the deposit. Sorry, the total amount of the interest earned divided by the total weighted sum of your deposit. Okay, that you make over this entire year, including your account balance. Okay, so then we just will try to use this to set up our useful equation. Okay, then here what we are going to do is we try to get the detail one by one. Okay, now first of all, so for the numerator, which refer to the total amount of the interest earned. Now, so then this is something that you know that already, so that you can easily put that in 9320. Okay, now then the only thing left is just the denominator, so which is what? The total weighted sum of the deposit. And then here in this problem, so you have 4 deposits. So one is your initial account balance, another one is the intermediate deposit. Okay, so here then for each amount, so you try to multiply by the time that it stay in the account. All right, so let's say for the first one, which is your A0, okay, and the amount is 120,000, and then you just multiply by 1 because it stay in the account for 1 year. And then for the second one, so which is S, so it is invest at time t/12, right? Isn't it? So then it stay in the account for 1 month t/12 year. Okay. And then so the second one will be what? No, sorry. I get it wrong here. It's only 1 minus t. And then for the second one, so the second one is 2s, and then you make it at time t plus 1 over 12. Okay, so then this is what you get. Okay, and then for the last deposit, then you make it at this part. Okay, so here, okay, then this will be what the total weighted sum of your deposit. Okay, so for each amount, you just multiply by the time it stay in the account. That's it. Okay, now, so here, okay, then we have this equation that which allow us to solve for the t. But of course, here, in order to make this equation work, so it looks like that you have to find what is the values of s. Okay, so you still need to resolve this problem. Okay, now so here, in order to get this, okay, so then we will what? Try to make use of some other condition. And perhaps one condition that you can try will be this, the interest that you earn, okay, 9,320. Okay, so here then this is what I do. Okay, now so remember that, okay, so the interest that you earn, okay, so remember to find the interest that you earn over the year. Okay, then you look at your account balance, right? Isn't it? And remember, the change in the account balance is caused by what? The interest that you earn. Okay, so which is your I. Okay, and then plus what? Plus your total deposit that you make. Okay, and then if you try to put this thing to the left, okay, then you will end up with this equation. Okay, so the interest that you earn will be what? Just the differences in the account balance minus the total deposit. And then here, okay, so you already know all the account balance and also the interest. Okay, then here, then you will only have the equation for the s. Then solving it, then you will get the s equal to 380. Okay, now so then given this, then now then we can go back to this equation, and then we can finish the job. So you just substitute s into this equation. Okay, then you will end up with this equation for the t. Okay, it looks complicated, but luckily it is just after some rearrangement, it's just a linear equation for this t. Then solving it, then you will get the t, which is equal to what? 0.305555551. Okay, so then that will be our t here, right? Okay, now so then given this, then what can I say about the first day of making the deposit there? Okay, now remember what does this t mean? Okay, so here, okay, so here in this diagram, so the t represent the time, okay, the time that has passed, okay, when you make the first deposit. Okay, so here, okay, you find that the t is 0.3055. Okay, so that means, okay, so you make the first deposit after this 0.3055 year. Okay, now and then if you want to know the exact dates of making the deposit, okay, then what you need to do is you just try to convert this one into the day. Okay, and here in this problem, so we assume that we have 360 days in a year. Okay, so that you can just multiply this t by 360, so then that will be what? 110 days. So that means the first deposit will be made 110 days after the 1st of July of 2016. And then let's assume that you have 30 days in a year, then the first deposit will be made on this 20th of October of 2016. Okay, so here, okay, then this is just another example about finding the dollar weighted weight the dollar weighted rate of return. Okay, now then given this, then now we will try to move on another indicator measuring the performance of the investment fund, so which is what we call time weighted rate of return. Okay, so here in order to motivate this concept, so let us try to revisit the concept of the dollar weighted average return. Okay, now so remember the purpose of developing this dollar weighted average return is try to measure the performance of the investment fund. Okay, and remember that this is just a simplified version of your IRR, isn't it? Okay, think of course intuitively, we expect that so this IRR should measure the actual amount of the interest earned by this financial instrument, right? Okay, but unfortunately here, actually this dollar weighted average return actually can be significantly affected by the deposit made within a year. So what it means is, so actually, so this IRR actually is also driven by the action taken by the investor in a year. So to give you some idea about that, so let us consider this experiment. Okay, now so here we consider that so there is a investment fund. Okay, so which is in this pattern. Okay, so this is your investment plan. Okay, then for this investment plan, so the story is something as follow. Okay, now first of all, at time 0, so your investor so will deposit the certain amount at time 0. Okay, and then here you are given that so for the first 6 months, okay, so then this fund value will be decreased by 20%. So that means if you invest at time 0, then at time 0.5, okay, so you will only get 0.8 s, okay, alright, so which the value is dropped by 20%. Okay, now and then here after this 6 months, okay, now then the investor can decide to make the additional action. So what he does is, so he can choose either he can make the additional deposit into the fund, meaning that he try to put more money into that even though the fund is losing money, okay, or he withdraw some amount, okay, meaning that taking some money out, okay, and then the last one is he just do nothing and just let the account move on. Okay, now and then here so you are also given that so whenever what he do, so in the coming 6 months, okay, so which is between 0.5 up to 1, okay, so then this fund value will be increased up by 40%. So that means that will be the amount that you get at time 0.5, then at time 1, then your fund value will be increased to 1.4y. Okay, so then this is what happened to this fund. Okay, now then what I'm going to do here is so we will try to make use of this dollar weighted average return to measure the performance of this investment fund. And then I'll go here is we will try to argue that actually this dollar weighted return will also depends on not just depends on the performance of the fund here, it also depends on what the investor do at the end of the 6 months. Okay, now and then here in order to do this comparison, so we will consider 2 investors. So one is Mr. A, another one is Mr. B. Okay, and then we will assume that so both of them will invest the same amounts into the fund initially. Okay, and then the only difference is so they will try to do different action after 6 months. Okay, so here for Mr. A, so he will do the following. Okay, so at time 0, so he deposit 5,000. Okay, and then after 6 months, so when the fund value decrease by 20%, okay, so at that point, so he will do the withdraw $1,000 from the fund, okay, because he realized that the fund is losing money. Okay, now so given this, so then So then this is what he do. Now, and then how much will he get after 1 year then? Okay, now then we can easily get it using the forward induction. Now, first of all, initially he got $5,000, right? So that means after 6 months, so this amount value will drop by 20%, right? So meaning that it will drop to $4,000. Okay, so which is a 5,000 times 80%. Okay, and then at that point it will withdraw $1,000. So meaning that the new account balance will be 3,000, right? Which is the money stay into the account, and then this fund value will be increased up by 40%. So meaning that after 1 year, so what he get will be 4,200. Okay, so then that will be the final account balance. Okay, now and then for Mr. B, so we try to do the similar phase. So first of all, he deposit $5,000. Okay, and then again, so after 6 months, so this account balance dropped to 4,000. But here, instead of withdrawing the money, so he tried to go aggressive and try to make the additional deposit $1,000. Okay, so he input $1,000 as well. So that your new account balance will go to 5,000. Okay, and then again, over this 1 year, so the fund value increased by 40%. Okay, so that this account balance, so for that this account balance grown to 7,000. Okay, then here, then this is what happened to Mr. B. Okay, so here, okay, then we have two investors investing into the same fund, but just they use the different strategy. Okay, then what I want to do is, so we will try to measure the weighted rate of return of each of these investment. Okay, and then what I want to argue is, so we want to see so whether this the dollar rate of return we obtain are the same or different. Of course, if it is the same, then that means this dollar rate of return will really measure the performance of the investment fund, which is independent of the investment action. So otherwise, if you find that these two numbers are different, then that means this IRR actually is also affected by the investment strategy made by the investor. Okay, now and here if you try to do the calculation, okay, just using the definition, so you'll find that for A, so you will get the rate of return is 4.44%. Okay, so to get this number, so again you just try to compute the total amount of the interest earned and then divided by what? The total amount of the deposit, okay, which is weighted. Okay, and then here throughout this and then here, okay, so throughout this year you only have one withdrawal, right? So which is treated as the negative value of your deposit. Okay, now anyway, okay, so you can use this you use the formula for the dollar rate of return, then you find that this one is 1.44%. And then similarly for fund B, so you can do the similar calculation, so you will get the IB equal to 18.18%. Okay, so here you can see that, so it looks like that this $2 rate of return is very different for Mr. A and Mr. B. So that means that actually this dollar rate of return is not just affected by the performance of the fund itself, but also depends on what? Depends on the strategy chosen by the investor. Okay, so that means actually this dollar rate of return actually is what is measuring the performance of the entire investment strategy, okay, including the action that you take and also the investment fund that you choose. Okay, so then that is So what we have for the dollar weighted rate of return. Okay. Now, but here let's suppose, okay, I'm just was is interest, okay, in looking at the performance of the financial instrument itself. Okay. Now then what should we do then? Now then of course here then the dollar weighted rate of return will not be that useful because it also affected by your investment strategy. Okay, so here, okay, then in order to do this, so we have to try to develop another useful notation that allow us to just measure the performance of your investment fund only. Then this notation will be called, this concept will be what I call time weighted rate of return. So which is a indicator to allow you to measure the performance of the investment fund only, okay, without considering the investment strategy. Okay, now then the question here is, so how do we get this, or how do we define that? Now and then again, in order to do this, so we will consider this cash flow diagram of this investment fund. So again, basically we apply the same setup as we did for the dollar weighted rate of return. So first of all, we have an investment fund with the initial balance A. Okay, and then throughout this year, so you will make some deposit. Let's call it C1, C2, Cn. Okay, if it is positive, then that will be deposit. Otherwise, that will be withdrawal. Okay, then after this N deposit, and after 1 year, then this fund this account balance of the fund will be equal to B. Alright, and then here what I want to do is, so I want to measure the performance of this financial instrument. Okay, now so in order to do this, okay, so let us try to state our goal. Okay, now so remember our goal is we want to measure the performance of the investment fund. So that means I want to measure so how much interest is being earned by this fund over the year, right? And more precisely, so let's say if you invest $1 at time 0, so I want to measure after 1 year how much interest do I get. Okay, now then so this is what I do. Okay, now and then here in order to do this, of course some people may say, okay, so then I can just consider the annual effective interest rate, but it looks like that it doesn't work for our cases because here here, okay, in this year, so you also make there is some deposit, right? C1, C2, Cn, so which is also affect your final outcome. Okay, so here in order to measure this EI out properly, so we have to try to rule out the effects of this deposit. Now and then in order to do this, so in order to measure this properly, okay, then this is what I do. Okay, now so let me do that here. Okay, now so here, okay, so we have the contribution that you make over this year. Okay, now then in order to measure this year out, so what I'm going to do is I will try to divide the whole time horizon into many small periods, so just like that. Okay, so then this is your period 1, and then this is your period 2, and then this is your period 3. Okay, and then that is your last period. Okay, and then what I'm going to do is for each period, so I will try to estimate the EIR over this particular period. Okay, and then of course of course, some of you may ask, so what is the reason of doing that? Because here, it will only focus on the EIR over this particular period. So here, because over each period, so there is no more deposit that you make, isn't it? So here, okay, then the change in the account value or whatever, so will be what purely represent the interest earned by the fund. Okay, so here, okay, then this is what I do. Okay, so here then let me try to let the J1, okay, to be my ER over in the first period, J2 is the ER in the second period, and then this J3 is the ER in the period 3, and so on and so forth. Okay, now then the question will be what? So how do we get this JK there? Okay, now so here let us focus on the first period. Okay, so maybe I'll try to write that here. Now, so to facilitate the analysis, okay, so I first try to define one notation, okay, so which is the BK. Okay, so here we will try to assume we will let the BK to be the account balance of the fund just before the deposit is made at time TK. All right, so that means, okay, so B0 will mean what? The account balance at time 0, and then B1 will be the account balance before you make the deposit C1, and B2 will be what? The account balance at time T2 before you make the C2, and so on and so forth. Okay. Now, and then here with this notation, so let us try to use that to get my J1, J2, J3. Now, first of all, let us start with the J1. Okay, which is the EIR over this period from 0 to T1. Okay, now remember initially, so the account balance is B0. Okay, and then at time T1, so it will grow to B0 times 1 plus J1. Okay, so if the EIR is J1, right? Okay, so for each $1 you deposit, then you get 1 plus JI. Okay, then if you have B0, then this is what you got, and then here this amount will be equal to B1. All right, so in that cases, so you got the equation for the J1, so that assuming that you have know all the account balance, then you get the J1 will be equal to B1 over B0 minus 1, isn't it? Okay, so here then this is what, how do you get the J1 property? Okay, now then once you get the J1, then you can move on to the second stage, that is so the J2. Okay, now so for the J2, so you can try to do it in a similar way. Okay, so let me write it down here. Okay, now so for the J2, okay, so then you consider timeline from T1 to T2. Okay, now so then basically we try to perform the same strategy. Okay, now so first of all, at time T1, your account balance before the deposit is B1, right? Okay, now and then at that time, so you make the deposit C1. So here, after you make the deposit, then the account balance will be B1 plus C1, isn't it? Now, and then again, assuming that it will earn the EIR J2 over this period, so that means after at time T2, so the amount that you get will be B1 plus C1 times 1 plus J2, and then this one should be equal to what? B2, right? Okay, the account balance before the deposit. Now, then again, you can use this equation and solve for the J2 immediately. Okay, then this is how do you get the J2. Okay, and then of course here in a similar fashion, so you can repeat the same trick. Okay, then you can get the J3 easily, so which is equal to what? Equal to B3 over B2 plus C2 minus 1. Okay, or more generally, if you consider any arbitrary period, okay, then you will get the you will get the EIR. Okay, the EIR JK will be what? Governed by this equation, And then solving this, then you get the JK will be equal to what? The account balance before the deposit at that time divided by the account balance, okay, at the previous period, okay, just after you make the deposit, okay, and then minus 1, okay, and that will be what? The formula, okay, for my EIR, okay. Now, then the next thing is, so after you get this EIR, then how do you get our final annual effective interest rate, okay. Now, and then you get this, actually it is not that difficult, okay. So remember that our goal here is, so we want to find the annual EIR of this fund. So meaning that if you deposit $1 at time 0, how much do you get at time 1? Sorry. So how much interest do you earn at time 1? Okay, so then this is something what you get. Then of course, in order to get this, so you first try, you need to assume that, so let's say if you invest $1, how much do you get at time 1? Okay, now and then here, let's say, okay, you already know the, so let's say you already know the EIR over this period, this n+1 period, okay, then actually you can easily get this final amount by the forward indexer. Now, so let's assume that you get $1 at time 0. Now, then over the first period, you earn the interest rate J+1, isn't it? So that at time T1, you will get 1 plus JI, isn't it? Now, and then over the second period, the EIR is J2, isn't it? So that at time T2, you will get 1 plus JI times 1 plus J2. Okay, and then here, then if you keep on looping this, okay, then at time 1, so what you get will be 1 plus J1, 1 plus J2, okay, and then 1 plus J n+1, okay, and that will be the final amount that you should get at time 1, isn't it? Okay, now and then here, okay, to measure the interest that you will earn over the year, then you just set this final amount to be equal to 1 plus I, okay, then here, given this, then you can easily deduce the equation for the I, so which is equal to this value, okay, and then here, so then that will be the final formula. Now, and then here, if you want to try to get the exact formula, okay, so here just recall your each JK is can be expressed in terms of the account balance at different period, right? Okay, so here, okay, then you just use this and substitute it into here, then you will get this final formula, okay. So in particular here, so given this, so you can write 1 plus JK equal to BK over BK minus 1 plus CK minus 1. Okay, then you just apply this to each of the term here. Okay, then you will essentially get this final formula for this return. Okay, then here, okay, then this interest AI, okay, will be what we call time weighted rate of return of the investment. So basically, it will be the interest rate that you can use to measure the performance of the financial instrument chosen, okay, by the investor, okay, and we expect that, okay, because of this, according to the derivation, so this value should be independent of the investor action. Okay, so then this will be just a summary of this definition of the time weighted rate of return. Okay, so I guess I'm not going to repeat that here, okay, because it's just same as what is said before. Okay, and then just one very small remark here. Okay, so when you want to compute this time weighted rate of return, so compare with the one about the dollar weighted rate of return. So besides knowing the account balance at the beginning of the investment year and the end of the investment year, so we also need to know so what are the account balance at the intermediate time. When do you make your deposit? So that means you need to know this BK, right? Okay, so actually, so this is something that you also need to know if you want to get this time weighted rate of return. Now, so as I've said before, so this time weighted rate of return so can measure the performance of the investment fund so without and ignoring the strategy taken by the investor. Okay, so to see this point, so let us try to look at the early example, okay, about the investment by the Mr. A and Mr. B. Okay, so remember that if I want to measure the performance of the investment fund using the dollar weighted rate of return, so we see so the values can vary a lot because it still depends on the action taken by the investor. Okay, and then here, so let us try to see so whether the time weighted rate of return can do his job. Okay, now so here, okay, what I'm going to do is so I will try to for each of the investor Mr. A and Mr. B, so I will try to calculate the corresponding time weighted rate of return and try to see whether this time weighted rate of return will give you the same answer for both investors. Okay, now so here in order to get this, okay, so let me try to write it here, okay, because we don't have too much space. Okay, so first of all, just recall this time weighted rate of return is just this product of it. Okay, and here, okay, so remember BK is what is your account balance, okay, at the time that you make the cave deposit. Okay, and then here in this formula, so we assume that there are n deposit. Okay, now and then here back to our cases, so we only have one deposit day. Okay, so which is 1/2. Okay, so in that cases, then this time weighted rate of return will be just equal to B1 B0 plus C0, so which is for the first period, and then the B2 over B1 plus C1, which is for the second period, and then minus 1. Okay, now and then here in order to get this number, so you need to get so what are the account balance at these 3 key days, as well the deposit C0 and C1, okay, that you make at time 0 and 1/2. Okay, now for the deposit, okay, C0 and C1, so this is easy. So first of all, at time 0, so at this point you do not have any deposit, so you just get 0. Okay, and then B0 will be what, 5,000. Okay, and then at 1/2, so at 1/2, so your account balance before the deposit is 4,000. Okay, now and then at that time you do the withdrawal 1,000, right? So remember when you do the withdrawal, so that will be treated as the negative of your deposit, so which is 1,000, and then at time 1, so which is the end of your investment period. Okay, so the B2 will be what, 4,200. Okay, so then given this, then you can now start to do the calculation. So here, so for the first one, that will be 4,000, and then this one will be 5,000. Okay, and then for B2, that will be 4,200. Okay, and then B1 minus C1 will be 3,000. Okay, then if you try to calculate this, so you will get the number will be let's see, so will be 12%. Okay, so here then that will be the case for the Mr. A investment account. Okay, now so here let us try to do the same thing for Mr. B as well. Okay, now so for Mr. B again, so we just apply the same formula. Okay, so again, okay, so the setup is essentially same as Mr. A, so that this is what you get. Sorry, it should be minus 1. Okay, then again, you try to punch in the number. Okay, so first of all, for B seal and C seal, that will be 5,000. Okay, because B seal is 5,000, C seal is 0. Okay, and then for B1, so that will be 4,000. Okay, now and then for the second term, so B1 is 4,000, and then for C1, because you make the deposit, so that you have plus 1,000, and then for B2 that will be 7,000. Okay, and then minus 1. Okay, then again, if you try to perform the calculation, so you will find that the answer will be again 12%. Alright, so here you can see, so we find that, so if you consider the time weighted rate of return, now whenever it is Mr. A or Mr. B, so the answer that you get are both 12%. Okay, so then actually it means this time weighted rate of return is insensitive to this investor strategy, so that this time weighted return will be useful for you to measure the performance of the investment fund only. Okay. Now, then given this, then we will try to look at more example about this time weighted rate of return. Now, so let us take a look on this example 12. Okay. So again, we consider an investment account which is active over this 2016. Okay. So first of all, initially, its initial balance is 85,000. Okay, now and then on 1st of June of 2016, okay, so the account balance is grown to 105,000, and then at that time you will make the additional deposit 32,000 into that. Okay, because the value is going to appreciate, right? Okay, but here after he made the deposit, and after 3 months, so which is the 1st of September, then this account value dropped to 112,000. Okay, so which is less than the earlier case, because on the 1st of June, okay, so after you make the deposit, so your account balance is supposed to be what, 137,000. Okay, but now the value is dropped by 25,000 in the September. Okay, then at that time, okay, so the investor try to withdraw some money from that to just try to reduce the losses. Okay, so here he withdraw the 35,000, so that the account balance dropped to 77,000 afterward. Okay, now and then at the end of December, so then this account value raised to 84,500. Okay, now and then here what I want you to do is, so I want you to measure the time weighted rate of return of this investment. So meaning that I want to know, so what will be the actual return of this investment, of this investment account. Okay, now and then here in order to do this, so basically we just will try to compute this time weighted rate of return. Okay, now so here, okay, then let us try to draw the cash flow diagram. Okay, now so here we consider 1 year time period, so time 0 will be what, just the first day of 2016, and then time 1 will be what, the end day of 2016. Okay, and then here during this year, so you make two deposit of withdrawal, right? Okay, so we should do that in 1st of June, so which is what, at time 5/12. Okay, after 5 months, and then another one will be on the 1st of September, so which is after 8 months, time 8/12. Okay, so this one you deposit 34,000, and then this one you take out 35,000. Okay, now and then here to get this time weighted rate of return, so you just use this formula. Okay, and here okay, because you got there are 3 periods. Okay, so that you will have 3 time altogether. Minus 1. Okay, so each term corresponds to each this first period, second period, and the third period. Okay, so and here the only thing left is just what you pick up all the numbers for this B0, B1, B2, B3, C0, C1, and C2. Okay, so actually it's not hard to get because all this data are available already. So you just try to put this number into the right place. So first of all, for B0, so that will be 85,000. Okay, and for C0, because at that time you don't have any withdrawal, right? So that this will be equal to 0. And then for B1, so that will be this 105,000. Okay. And then for C1, so at that point you make the deposit, right? So you got 34,000. Okay, and then for B2, that will be 112,000. Okay, and then of course for this C2, because you do the withdrawal, right? So then that will be the minus 35,000. Okay, now and then for B3, okay, so that will be what's the account balance in the last day. So then that will be 84,500. Okay, so then essentially we have all this amazing number ready. Then actually you can just press your calculator and you can easily get the final answer. So then after some calculation, you will find that the answer will be what? Around 10.824%. So which will be what? The actual return of your investment account. Okay, so here then this is one example about the time weighted rate of return. Now, and then perhaps let's try another one, which is a little bit more complicated case. Okay, now so here in this example, so you are given 2 investment accounts. Okay, and here okay, so again we will consider the activity of these 2 accounts over a particular year from 1st of January up to the last day of the December. Okay, and again just like the earlier example, so I will tell you the account balance before the deposit at some key day. Okay, and where you will have some deposit or whatever. Okay, and here okay, so I will also give you the amount of the deposit. So if this amount is positive, okay, then that will be the ordinary deposit. But if this deposit is let's say a negative number, let's say 50 minus 15, okay, then that will be equivalent to withdraw with the amount $15. Okay, now so then this is the given information. Now and then here let's suppose that so the dollar weighted rate of return is of these 2 accounts are the same. Okay, then my goal here is, so given this, so I want to find so what is the time weighted rate of return of account B, so which is this one. Okay, now so here in order to get this, so actually it's not that difficult. So I would say first of all you can first try to set up the formula for the time rate of return of account B first. Okay, so as I have said, so we always start from our last target. Okay, now then this is what we do. Okay, so first of all let us first recall the formula for the time weighted rate of return, so which is equal to this. Okay, now and here for this account B, so there are 2 activity over this 1 year time horizon, right? So one is what? One is in the first one is in the 1st of May, right? Okay, so which is what at the time after 4 months. Okay, so remember the 1st of January is time 0, and then the 1st of May will be after 4 months. And then at that time, so you have a kind of deposit 1.5x. Okay, and then in the 1st of September, so which is at time 8/12, so you have another deposit 2x. Okay, and then at time and then the game is over. Okay, now then again, so there are 3 periods, so that's so your time rate of return will consist of 3 times. Okay, so that will be something like this. Then of course here, what you need to do is that you just punch in the number. Okay, now first of all, for the B0, B1, B2, B3, so this one is easy. Okay, because these are the number available already. So let's say here, for B0, so that will be 100, and then for B1 that will be 110, and then B2 is 110, and then B3 is 185. Okay, and then here for C0, so that will be 0, right? Because no deposit make at time 0, and then the only deposit will be 1.5x, which is at this point. Okay, and then C2, which is equal to 2x that you make at time 8/12. Okay, and here it looks like that in order to continue the game, so actually what we need to do is you just need to get what is the s. Okay, then we are done. Okay, now so here in order to get this unknown s, so what we do is we will try to make use of this given condition. The weighted rate of return of these 2 accounts are the same. So here in order to set up this useful equation for this s, so what you need to do is you try to compute the weighted of return of these 2 accounts respectively. Okay, so here just remember, okay, so your weighted of return is just equal to what? The total amount of the interest earned divided by what? The total weighted sum of deposit. Okay, now and then here, okay, so let us try to do this one by one. Okay, so first of all, for the interest earned, so remember to get this interest earned, so we consider the account balance, right? The differences of this, and remember the differences of this account balance is just equal to what? Is equal to the total amount of the deposit that you make. Okay, and then plus the interest that you earn. Okay, now and then here for the account balance, so we have this initial balance 100. Okay, and then the account balance at the end is 130. So we just need these 2 numbers. Okay, now and then so for the deposit, so you have one deposit s, another one is this minus 2s, so which is your withdrawal, right? Okay, so that's why here, and this is what you get. Okay, so you got s and then plus minus 2s. Okay, and then this one is your I. Okay, and then A1 is 130, this one is 100. Okay, then here, then that will be what your, so you put all these terms to the left. Okay, then that will be your numerator. Okay, now and then here, how about the denominator there? Now for the denominator, that will be the weighted sum of the deposit. Now first of all, this is for the initial balance. Okay, so which is the amount that stay in the account for 1 year, and then the second one will be what? The s, right? So which you make at 1st of May, so which is at time 4/12. Okay, so that's why you got 1 minus 4/12. All right, and then the next one will be the minus 2s that you make in the 1st of October, so which is at time 9/12. Okay, then it will stay in the account for 1 minus 9/12 year. So that's why you multiply this constant. Okay, now then that will be your denominator. So here then that will be the dollar weighted rate of return of account A. Then you just do a little bit algebra. Then you will have this symbol. Then you will have this IA in terms of S. Then similarly, you can also do the same trick for the account B. Then you will find that the dollar weighted return of account B will be equal to this number. Okay, this one. Okay, then after this, remember because these two dollar weighted of return are the same, right? So that you can just equate them, then you will get a quadratic equation for the S. Now, and then here, if it is a quadratic equation, so you should end up with two answers. Okay, now so here, okay, then you will get one. So one of them will be equal to 10.78. Another one is a negative number. Okay, and then the question here is, so which one should we accept that? Okay, and then of course some of you might probably say, okay, so here, okay, so some of you may say, so I will try to accept the positive S, okay, because the S cannot be negative. Now, but here just be a little bit careful, because here in this table, so actually we accept this S can be positive or negative, right? Because S, if positive, then that means it's just the deposit. Otherwise, if it is negative, then that will be the withdrawal. So that means theoretically, so this number can be positive or negative. Alright, so it looks like that here we cannot just simply reject the negative one just by saying that S is always positive. No. Okay, now but here in this okay, in this calculation, so we finally will reject the second one. Why do we reject that? Now, so here in order to get this, so let us try to try to look at this table again. Okay, now and then let's assume the S is really equal to minus 226. Okay, now then here take a look on the first deposit here in the account A. Okay, now so that means in the 1st of May, so if your S equal to minus 226, that means that at that point you are withdrawing $226. But the problem is it feasible? Definitely not, right? Because here your account balance at that time is only 126. So how come you can withdraw $226 there? Okay, so it looks like that because of this inconsistency, so it looks like that the S cannot be equal to minus 226. Okay, and because of that, so we will try to reject the second one. Okay, now so here then this will be how do we find the S. Now then once you got the S here, then now then you can try to punch in into this formula. Okay, so with these choices of this BI, okay, then you can easily get the final answer. Okay, so which is equal to this 34.8489%, which is your time weighted rate of return of the account B. Okay, so here, okay, then this is just one more example regarding this time weighted rate of return. Okay, now and then here, okay, so before I start, so let us try to look at one more example. So here, let me try to skip the example 14 and jump directly to example 15. Okay, now so here in this example 15, so we have this scenario. So first of all, so we have two funds available in the market. Okay, so let's call it fund A and fund B. And then here, in this problem, so you are given the accumulation function of fund A and fund B are 1.09 to the power D for fund A and 0.007t for fund B respectively. And the t can take any value between 0 and 1. Okay, and then here in this problem, so we will consider a scenario that so we have a fund manager is going to offer a new fund, and this fund will be a combination of this fund A and fund B. So which is typically the case in real life because usually a investment fund should consist of different kinds of stock, fund or whatever. Okay. Now so here then we consider a fund consists of this fund A, fund B. Alright, and then here for this new fund, so the rundown will be as follows. Okay, so first of all, we consider a 1 year time horizon. Okay, now and then at time 0, so the investor will invest $10,000 in this fund at time 0. Okay, now and then here for this, and then for this fund manager, once he receive this money, then what he do is he will invest 30% of the capital in fund A and then 70% of the capital into fund B. Okay, so here like in these cases, so if he invests $10,000, so that means you will have $3,000 going to the fund A and $7,000 going to fund B. Okay, now and then here, so this is what happened at time 0. So then after this investment at time 0, then we will wait until time 0.5. Okay, now then at time 0.5, so the investor is going to increase his investment amount. In particular here, he will make the additional deposit $5,000. Okay, now then after he deposits $5,000, so then what the manager try to do is, so at the same time, he will also change his investment strategy. So in particular here, they will try to adjust the amount of the money stay in each the fund A and B. Now so remember, initially, so he allocate 30% of the money in A and 70% in B. Okay, and then at time 0.5, they change the strategy. So in particular here, so they will try to reallocate all the amounts, okay, including the deposit and the money that already stay in the fund as follow. So here he will deposit 80% of the capital into fund A, okay, but 20% will go to fund B. Alright, and then here, okay, so that will be the new allocation. Okay, and again, so this amount, remember, it will contain the deposit and also the account balance. Okay, it will affect both. And then after this, okay, so then we just keep it until time 1, then then that's it. Okay, now and then here, so then this is what our the rundown of this build fund in this 1 year. And then what we want to do is, so I want to measure the performance of this investment fund. Okay, then to do that, then we will try to use the time weighted rate of return of this investment fund. Okay, now so how do we do that side? Okay, now so here again, in order to do this, so we first try to set up the formula properly. Okay, -1. Alright, now and then here, because in this investment problem, so there are altogether 2 periods involved. Okay, period 1, period 2. So that's why here this will be equal to okay, so then that will be the formula for your time weighted rate of return. Then again, just like the earlier cases, then the only thing that you have to do is you just need to get the number properly. Okay, now so first of all, let us start with the C0 and C1, so which is the amount of the deposit and the withdrawal. So that one is relaxing. So first of all, for C0, definitely it will be equal to 0 because low deposit make at time 0. Okay, and then here, okay, for C1, so that will be $5,000. Okay, this is your additional deposit. Okay, now and then the only thing left is just to get B0, B1 and B2. Now for B0, so because initially you invest $10,000, so that means this will be your account balance. Okay, now then the only thing left will be just what. So how about B1 and B2? Now then that one will be a little bit tricky because at this point, okay, so we don't have any that information about this B1 and B2 are given. So it looks like that you have to try to get it by yourself. Okay, now so here how do we get this then? So basically we just given the investment rule chosen by the fund manager. So actually you can try to get this account balance by the forward induction. Now so let me show you how to do that. Okay, now so let us start with the B1. Okay, now so remember okay, at time 0, so you when you invest $10,000, so you will have $3,000 going to the fund A, right? 30% of that. Okay, and then at the same time you also have 70%, which is 7,000 going to fund B, right? Okay, so here because you don't have any activity between 0 and time 0.5, so then the account balance at time 0.5, which is for B1, will be just the future value of your account balance in fund A and fund B, isn't it? Now so then this is fund A, right? So 3,000 times the corresponding accumulation function, and then for fund B, then that will be your initial deposit times the AB 0.5. Okay, and then here you have the accumulation function already, so you just put that in. Okay, then you can easily get this account balance, so which is your B1. Okay, so here then we got the B1 property. Now then the next thing is, so how about the B2? Now so remember B2 is what is your final account balance at time 1. Okay, now and then to do that, so remember there is another action taken by the fund manager, right? Okay, so he will reallocate the money. Okay, and of course at the same time the investor also make the additional deposit. Now so then how do we handle that? Now first of all, before any action taken by the investor or the manager, so then this is your account balance, right? Okay, then of course here after you make the additional deposit, okay, $5,000, then your new account balance will go to 15377.09195. Okay, now and then remember, according to the given condition, so the fund manager will allocate 80% of this money to fund A and then 20% will go to the fund B, right? So that's why this is what we have. Okay, so you have 80% go to fund A, and then you have 20% go to fund B. Okay, now and then here based on this, then you can calculate what happened at time 1, so which is a B2. So then again, so then that will be what the account balance in fund A and fund B. So for fund A, so you have invest 80% of this total wealth, right? Okay, then at time 1, then this value will be grown to this final amount, so that will be the fund A. Okay, and then for fund B, so which is similar. So remember, you allocate 20% of the role in fund B. Okay, then at time 1, so the value will go to this amount. Okay, just take the future value. Okay, multiply by this accumulation function. Okay, so here, okay, then after some calculation, so then you will get the B2 successfully. So which is your account balance at time 1. So once you have that, so actually we are done. So you just punch in all the number here. Okay, so B0, B1, and then B1, C1, B2. Okay, then you can easily get the final answer. Okay, so which is what the time weighted rate of return will be equal to 8.128%. Okay, so here, okay, then this is just another example of finding this time weighted rate of return. So personally, I would say, so getting this time weighted rate of return is not that difficult. Okay, it's just a very simple accounting exercise. So basically, we just first of all, you first try to see so how many periods are involved in your investment gap. Okay, and then you decide how many times should you include. Then the next thing is, so you to get this, then you just try to do some accounting and try to determine so what is the amount of the deposit at different investment day and what is the corresponding account balance as well. Okay, and sometimes if they are given, then of course you just punch it into that and do the accounting. But sometimes, okay, let's say in this example, so you don't have this information explicitly given, then you have to try to get it, okay, using this accumulation function, okay. But never mind, okay, it just the only difference is just the calculation is a little bit more complicated. But I would say conceptually, actually, there's nothing new. Alright, so here then basically we have finished this time weighted rate of return, okay, and then that is all about this topic 5. So basically in this topic 5 we just first of all we have developed 2 criteria to examine whether the investment project is profitable or not. Okay, so one is the net present value, another one is the IRR approach. Okay, and then after that, so we also developed 2 indicators to to study the performance of your investment fund over a year. So one is the dollar weighted rate of return, so which is the indicator that you measure the performance of your investment over a year. Okay, and then according to what I said before, so this indicator will include the performance of your investment fund, okay, plus your investment strategy. Okay, so which is IRR base. Okay, and then for time weighted rate of return, so that will be little bit a slight modification. Okay, we try to measure the performance of your investment fund only, okay, and which is independent of strategy. Okay, so here, okay, I would say though depend on different situation, okay, then you just try to pick up the appropriate one to examine the performance. Okay, so if you are asking for, let's say I want to evaluate the entire investment including my strategy, then you should choose your dollar weighted rate of return. But just if I just want to investigate the performance of the investment fund, okay, so that I can decide which financial instrument that I'm going to choose, then you should consider time weighted rate of return. Okay, so here then this is what I want to say about this topic number 5. Okay, so then I guess that's it. Alright, so then next time, okay, then we will move on to the new topic about this term structure of the interest rate. Okay, so that's all for today. Have a nice day.